everyone. Today I will finish up section 7.3 and then tomorrow we'll start on the properties of logarithms. So just a couple housekeeping duties here, things you're expected to know and to be able to do when you take an exam, a quiz, or test. So yesterday we were looking at exponential and log functions. We talked about the log function being the inverse of an exponential function and the exponential function being the inverse of a log function. So we're going to take a look at some things, some properties that we've already looked at, but which are important as we move ahead in this chapter. So special property, and these special properties aren't so much special. They're just really a consequence of what we know about exponents. And what do I mean by that? Well, if I take any number like 5 and raise it to the first, that's just 5. Okay. Or if I take 5 and raise it to the 0, that's just 1. Okay, so that's a consequence of exponents. And so we have these rules for special properties of logarithms. We say log base b of b is equal to 1. Well, why? Because b to the first is just equal to b. Okay, again, it's not so much a special property of logarithms as it is a consequence of working with exponents. Any number raised to itself is just that number. So for example, again, they give us log base 10 of 10. Well, why? Because 10 raised to the log base 10 of 10 equals 1. Why? Because 10 raised to the first is equal to 10. Again, a consequence of exponents. And then a logarithm of 1. Log base b of 1 is equal to 0. Why? Because b raised to the 0 is equal to 1. Again, any number raised to 0 is equal to 1. So here we have a log base 10 of 1 equals 0. Again, why? Because 10 raised to the 0 is 1. It's special properties of logarithms, or I like to say consequences of exponents. Now we have something called the common log, and we call it common because it comes up common in scientific applications. Well, the common logarithm has a base 10. Okay, so we've been working like with base 2, base 3, base 4. The common logarithm has base 10. And generally we don't write 10 when we use common logarithms. So for example, we've been working with like log base 2 of x, log base 5 of x, log base 1/2 of x. But when we're talking about base 10, we generally don't write 10 as the base, because it's understood that if I just have this log of x, it's understood that is log base 10. We generally don't write the 10 because it's understood that we're talking about base 10. Okay, so if no base is written for a logarithm, the base is assumed to be 10. For example, 5 equals log base 10 of 5. Yeah. It seems strange. Log base 10 of 5. Oh, I see what they're doing. Okay, so this was kind of there. We had to bring that over. So log base 10 of 5 equals. So that's what they were saying. I was going to say that didn't make sense to me. Okay, so again, if no base is written, we assume that to be base 10. Okay, now the thing about that is that we actually have, if you have a graphing calculator, and I'll show you, you actually can evaluate base 10 logs with your calculator. You see here right there we have log, L-O-G, so that's base 10. So for example, if I say log base 10 of 10, well, that should be 1. Log base 10 of 10 is equal to 1. Okay, if I said log base 10 of 0.01, which is 1 over 100, well, that should be negative 2, because 10 raised to the negative 2 is 1 over 10 squared, which is 1 over 100, and so that should be 0.01. Yeah, so that should be negative 2. And again, if I said, what's log base 10 of 1,000? That should be 3. Okay, because 10 to the third is 1,000. All right, so your calculator has a common log right there. Your calculator, common log. Right, so let's go back. You can use mental math to evaluate some logarithms. So again, log base 10 of 0.01, well, I just did that. That's -2, because that's 10 raised to -2 is equal to 1 over 100, or 0.01. Okay. Now, when you have a test or an exam, okay, we require that you do state the domain and range, the asymptotes, if you will, of the log or exponential function. So here we have the exponential function y is equal to 2 raised to the x, and you will be expected to graph that. And so that was graphed here, and I chose x values of -2, -1, 0, 1, and 2. Okay, so that was my domain, and for the exponential function, we can use any x. So the domain, so that would be all real numbers, as we see there. But the range, again, we have a y, we have an asymptote for that function. Okay, that asymptote. So that graph hugs that line y is equal to 0. So my range then will be y is greater than 0. That's my asymptote. Y is greater than 0. Okay, so that was for y is equal to 2 raised to the x. The inverse function then will be log base 2 of x. So log base 2 of x. And so as before, we can just switch the x and y. So my x becomes my y's here. And then my y's becomes my x's there. And so I graph that. Now, because we switch the domain and range, then our domain and range for the inverse is going to be switched as well. So here, because my range was y is greater than 0, now you'll see that it's the domain for the inverse is going to be x is greater than 0. And you can see the vertical asymptote there. So if you take a look at that red graph, okay, we have a vertical asymptote at x is equal to 0. In other words, that function y is equal to log base 2 of x will never cross the y-axis. It will hug the y-axis. The vertical asymptote is x is greater than 0. And then the range is all real numbers. Again, we just switched the domain and range. Okay, but our domain now is x is greater than 0 for the inverse. It's not y is greater than 0. Even though we switch this, that, we have to switch the variable as well. Remember, we're switching the x and y's. Right, so you should be able to state the domain and range of an exponential function and its inverse. And graph it. So, and on the test, and particularly when you guys get to pre-calculus, we do require you to graph or indicate specific points, at least 3 points on these graphs, on any graph. And I did that there. Okay, so you should be able to graph correctly. So this was the point, -1 and 1/2, and then 0, 1, and then what was that, 2, 4. So again, when you graph, I do want you to indicate specifically points on that graph. And what I mean by that, you should indicate like, hey, that is that's -1.5. And that point here, this is 0, 1. And then this point here, that is 2, 4. So when you take a test, you will be required to list specific points. And then ditto for that one there. See, that was what, 2, 1, looking at my or 1, 0. I'm sorry, so that would be 1, 0. And here, that point was 2, 1. And that point there was 4, 2. So list specific points. Okay. Now on the test again, so like this whole question may be worth 7 points, and again you get 5 points for your table, and you get 2 points for graphing. And why 2 points for graphing? Well, because graphing is nothing new to you. We've all been graphing on the coordinate plane back in 5th and 6th grade. All right, so there. Just be expected to be able to state the domain and range of the exponential and log function in graph. And then likewise, let's see here, I can take a look at another one. So here we have our function f of x is equal to 1/2 x. And again, you would be required to graph these, so we'll use points from x from -2 to 0. And when we do that, 1/2 raised to -2 is 4, 1/2 raised to -1 is 2, 1/2 raised to the 0 is 1, 1/2 raised to the 1 is 1/2, and 1/2 squared is 1/4. And there you see that's graphed. And again, for that one there, so that's this function here. So this is the function f of x is equal to 1/2 raised to the x. Again, the domain for that, as I've listed, will be all real numbers, but the range would be y is greater than 0. Again, we have a horizontal asymptote. We have a horizontal asymptote there for that function here. And then when we graph the inverse, we switch the x and y's. The inverse would be log base 1/2 of x. And so now my x's will be 4, 2, 1, 1/2, and 1/4. I just switched the x and y's. And then we graph that. And so that one will look, so that's this graph there. And so that would be log base 1/2 of x. Okay. And there, the domain would be x's, so the domain now would be x is greater than 0. I have a vertical asymptote for that graph. X is greater than 0, but the range will be all real numbers. Again, we just switch the x and y's in the domain and range. Okay, so just reviewing a couple things with you and what you should be expected to do on the quiz or test. So know how to graph the function and its inverse, state the domain and range, and then let's see here, what was the other points? Okay, understand that if we don't have a base for log, if I just have log, okay, if I have log of like 5, what we mean is log base 10 of 5. Even though we don't write that. And again, you can actually evaluate that with your calculator. So if I go back, so come on, I guess I have to. So let me, so what would log base 10 of 5 be? So if I go, comma log base 10 of 5. That's 0.6989. Oh, an important point too. I want you guys to notice that with with my especially my log functions, log base 2 of x, which is this, I want you to know that the domain is x is greater than 0. Okay, so so this is my log function here. The domain is x is greater than 0. Domain is x is greater than 0. Unless we make a transformation, that's always the case. If I go back to this one, again, this is my log function. The domain is x is greater than 0. Now your calculator can easily verify that, because if I go here and I say, so remember the domain is x is greater than 0, so if I say what's what's log of 0? Well, I can't, my domain can't be 0. It's greater than 0, okay? So I should get an error, and I do. Okay, you see that? But in other words, you can't take the log of a base of any log. You can't take the log and where your input or your domain is not greater than 0. It just can't happen. So, all right, so if I want like log of my -1, that's going to give me an error too. Impossible. All right, so the domain for the log function is always x is greater than 0 unless we make a transformation, which we'll do later on. Very important point. Okay, so we finish up section 7.3, and tomorrow we'll look at properties of logs.